Hi, my name is Vince Carrion, and I'm a Senior Product Manager on the Amazon EFS team. We're really excited to be here. We have quite a bit planned for this webinar. We'd love to talk about enterprise applications with Amazon EFS. So today we're going to start with an intro to Amazon EFS. We'll then take a look at some enterprise applications and how they're using Amazon EFS. Then we'll go over some things to consider as you do functional and performance testing, as well as what to consider when choosing appropriate performance options to meet your needs. And then at the end, we'll leave some time for any Q&A that you might have. So let's get started. When and why to use Amazon EFS? Well, what do you think about when selecting the storage to use for your application? Well, there are really three main things to think about. First, what type of storage makes the most sense for how your application is or will be written? Different types of storage offer different interfaces, semantics, and permissions models. The features and performance that different storage offerings provide and how they meet your needs is another thing to think about. And lastly, the economics of the solutions that you're considering. Let's talk about each of these in turn. So first, there are generally three types of storage: file, block, and object. Now, file storage is data that's stored as files in a directory hierarchy with particular metadata associated with each file. In other words, your data is stored natively in a file system format. Now, when we talk about file in the enterprise context, it's data that can be accessed over a network by multiple clients at the same time. And you could think of it as network-attached storage. With block storage, it's a disk or set of disks in which data is stored directly in chunks called blocks. The disk or set of disks is attached to a single computer, and you can have your operating system work with block storage such that the operating system presents the data in a file system format while storing the raw data as blocks. And you could think of this as local attached storage or local attached disks. With object storage, data is stored in a container called an object that is identified by a unique key. All objects are stored in a flat space, in other words, not a hierarchical structure. And it provides a simple API to get and put data based on key. And commonly, that API is called over the internet. Now, why is file storage so popular? Well, first, file storage is popular because it works natively with operating systems. Operating systems are designed around file storage, and file systems are the abstraction used for displaying data to end users, and operating systems provide the file APIs to allow applications to access data. And file storage is popular because it provides shared access while providing consistency guarantees and locking functionality. Guarantees on how data is updated and the ability to take out locks on files or portions of files is super useful for distributed applications with multiple writers and readers of that same set of data. And lastly, file storage is popular because it provides a hierarchical namespace. And a hierarchical namespace is a helpful and natural way to organize and think about your data. Now, another aspect to consider when choosing your storage type is the performance of that storage. Now with block, it's generally the lowest latency storage type, but doesn't scale to the throughput levels of file and object. And block storage is ideal for database applications, as databases are latency sensitive and commonly that database is run on a single computer. With file, it's generally designed for low consistent latencies, but it's also designed to scale to tens of gigabytes a second of throughput. And with object storage, it provides the highest level of throughput scale, but it's not designed for latency sensitive applications. Now, you're here because you're thinking at least about file storage for one or more of your workloads. Now, we launched Amazon EFS about 1.5 years ago, but before EFS, if you wanted file storage on AWS, you need to do it yourself. And here's an example of what that setup would have looked like. Well, typically you'd have mirrored setups in at least 2 availability zones for failover and data durability reasons. One would be your primary AZ, and the other your backup. You'd have a file server running on an EC2 instance as part of your setup in each availability zone, and storage volumes, or EBS volumes, attached to that file server. Data would be replicated synchronously or asynchronously across availability zones, but you would be responsible for operating the file servers and the disks and replicating the data and managing failover. But now we have Amazon EFS, which is our native fully managed file service. Now, when we designed Amazon EFS, our core tenets were to make it simple, elastic, and scalable, on top of a foundation of high availability and durability. So what makes it simple? It's fully managed. There's no hardware, network, or file layer to worry about. You can create a scalable file system in seconds, and with simple pricing means simple forecasting. We'll get to that in a second. In terms of elasticity, file systems can grow and shrink automatically as you add and remove files, and there's no need to provision storage capacity or performance. And you only pay for the storage that you use with no minimum fee. And scale-wise, file systems can grow to petabytes of capacity. Throughput scales automatically as file systems grow, and you have consistent low latencies regardless of file system size. Amazon EFS also supports thousands of concurrent NFS connections. And Amazon EFS is designed, again, to be highly available and durable. Every file system object is redundantly stored across multiple availability zones in a region. It's designed to sustain an availability zone offline condition, and superior to traditional NAS availability models and appropriate for production or tier 0 applications. We'll get to that in a second. Now, we designed Amazon EFS to serve the vast majority of file workloads, covering a wide spectrum of performance needs, from big data applications that are massively parallelized and require the highest possible throughput to single-threaded, latency-sensitive workloads. Here's an example of some of our customers today. Now, one aspect of features that you want to think about is what security model and what features come with your choices. Well, with Amazon EFS, it provides a variety of mechanisms to control access to your data and your file system resources. You can control network traffic using Amazon VPC security groups and network ACLs. So in this case, you can control which instances in your VPC have access to your file systems. You can control file and directory access using standard POSIX permissions. And you can control administrative access using AWS IAM. And in August of 2017, we launched encryption of data at rest, allowing you to encrypt your data with a key managed through AWS Key Management Service. You can access your EFS file systems from EC2 instances in your VPCs, or from servers in your corporate data center over Direct Connect. And lastly, you can access your EFS file systems from your VMware cloud on AWS software-defined data centers. Going back to the economics, again, you pay one flat rate just for the data you're storing. It's not a provision model, it's fully elastic. And you can see our costs in the various regions below. Now, earlier, we talked a little bit about how you would need to do this yourself before EFS. However, doing it can really get quite costly. First, you have EC2 instance costs for the file servers, EBS volume costs for the storage, and you have inter-AZ data transfer costs for replicating that traffic between availability zones. As you can see here, the do-it-yourself solution would cost about $540 a month for 500 gigabytes of storage. In this example, storage costs would be about $120 a month for two 600 gigabyte EBS volumes, because you would need to over-provision. Your server costs would be $290 a month, and the inter-AZ traffic would be $130 a month for a pretty standard workload. And in this example, EFS is 70% cheaper than doing it yourself, and it's simple, and you only pay for the storage that you use. EFS is available in 7 regions. We just announced that we're available in our newest region, US West, Northern California. And we're actively working to get EFS in more regions coming soon. And EFS is a core part of a rich set of storage building blocks. We have our core storage services, EFS for file, EBS for block, and S3 and Glacier for object. Now, I want to shift a little bit to talk about enterprise applications and Amazon EFS. With enterprise applications, we hear from customers who are using EFS for their enterprise applications, and they tell us zero downtime, running 24/7 is the expectation. They tell us that availability, agility, and flexibility are key. The vast majority of enterprise applications access data via file system interface, supporting common file level protocols and permissions. Now, as businesses move to the cloud, they require highly durable and scalable storage that seamlessly supports their existing enterprise applications and tools without retooling. And Amazon EFS provides that seamless support. You can access your data through standard file system interface and semantics. Amazon EFS is elastic, it's highly available, and it's durable. Now, I'd like to share some examples of how some of our partners have integrated Amazon EFS for their customers who are using their applications on the AWS cloud. Atlassian Jira. Atlassian Jira is a software development tool used by Agile teams. And Jira Service Desk Data Center provides IT service management software with high availability and performance at scale. Now, these applications use Amazon EFS as a shared file system to store artifacts in a common location that is accessible to multiple Jira nodes in multiple AZs. And by taking advantage of EFS's distributed architecture, customers are able to achieve higher and higher levels of availability. And Confluence is another Atlassian product that has found Amazon EFS to be a great fit for their customers. And Confluence is a team collaboration software that changes how modern teams work. And Confluence Data Center is a self-managed solution that gives customers high availability, performance at scale, and disaster recovery for uninterrupted access to Confluence. For this application, customers use EFS as the shared file system, that common data source that contains the attachments and other files needed by the multiple Confluence nodes. Files like attachments or avatars, plugins, they're all stored in an elastic shared file system that all Confluence nodes can access. And Atlassian notes that for jobs that rely heavily on downloading these resources, Amazon EFS can significantly improve your build time. Here again, customers are able to take advantage of EFS's ability to be accessed by multiple instances in multiple availability zones for high availability. Informatica PowerCenter is a proven hybrid data integration tool that transforms fragmented raw data from any source at any latency into complete actionable information. And with PowerCenter, you can integrate data from on-premise data sources and from data from your AWS services. In this instance, customers using multiple nodes, EFS serves as that shared file system again that can be accessed from multiple instances in multiple AZs. IBM MQ is messaging middleware that simplifies and accelerates the integration of diverse applications and business data across multiple platforms. It uses message queues to facilitate the exchange of information and offers a single messaging solution for cloud, mobile, IoT, and on-premise environments. IBM attests state and persistence is vital. We do not lose messages. Both IBM and their customers also want higher and higher availability, and they got both through Amazon EFS. In their quick start, the IBM Queue Manager is in an auto-scaling group, and in case of a failover, the MQ server is brought up in a separate AZ, but because that data is stored on Amazon EFS, nothing is lost, and the server carries on as if nothing has happened. TIBCO EMS is fully supported on AWS using Amazon EFS. TIBCO EMS implements the Java Message Service framework to provide a uniform messaging interface for enterprise applications. It connects other messaging services directly and integrates with other application types and services using TIBCO BusinessWorks. And TIBCO EMS customers require 24/7 operations and zero downtime. And they can take advantage of shared storage, in this case Amazon EFS, to persist data for guaranteed message delivery for queues and durable topics, as well as metadata and session information for their clients. For customers using TIBCO EMS with Amazon EFS, customers can get predictable, consistent performance and lower infrastructure costs. Now, these are just a few examples of enterprise applications that are making the most of Amazon EFS. You can find more information or even try a demo for yourself by viewing the quick start guides on the AWS website. Well, moving forward, let's take a look at some of the technical considerations you should consider when deploying enterprise applications to the cloud using Amazon EFS. We'll also describe some best practices and some tips for success. Now, first, a question that I sometimes get is whether I should use EBS or EFS, and how do I really think about that question? So here's a simple framework on how to think about that. If you have an application or use case that requires a file system and requires multi-attach or requires gigabytes a second of throughput or needs multiple availability zone availability or durability or requires automatic scaling of storage, then you really should think about using Amazon EFS. Now, for functionality testing of your application with EFS, the good news is that things really should just work. EFS is standards compliant, such as POSIX compliant and NFS 4.0 and 4.1, which is what most enterprise Linux applications are designed to work with. However, again, you should always test, always use your actual application and use your actual workflows. Now, to support a broad spectrum of workloads, EFS offers two different performance modes. The first mode is the general purpose performance mode. It's the default performance mode and really the best choice for most applications and workloads. It's ideal for applications including web serving, content management, software build systems, and general purpose file-based workloads, and it offers the lowest latency. The other performance mode is our max I/O performance mode, which is really designed for large-scale, scale-out architectures and workloads. Virtually unlimited amount of storage and IOPS are available for the max I/O file system, and you should really consider it when you have to scale out again to hundreds or thousands of instances. However, there are trade-offs. With the general purpose performance mode, there's a 7,000 I/O per second limit. So if your application requires low latency access and can live within a 7,000 IOPS model, then the general purpose performance mode is ideal for you. However, if you need to scale out to hundreds or thousands of instances and need more than 7,000 I/O per second, then you might want to try the max I/O performance mode. And the trade-off there is with max I/O, there's a slightly higher file system operation per second latency. Again, test your application and see which performance mode works best for you. If you do select a general purpose performance mode file system, we do expose a CloudWatch metric, %IO limit. And this allows you to monitor how close you are to the 7,000 IOPS as a percentage. So as you test, you can monitor and see where your workload sits within this threshold and see if the general purpose or max IO performance mode would work best for you and your application. Keep in mind that due to the per operation latency of EFS's distributed storage design, The overall throughput generally increases as the average I/O size increases, since that overhead is amortized over a larger amount of data. And by I/O size, I mean the amount of data that you're reading and writing in a single operation. And you can see here the difference between 4 KB all the way up to 16 MB. And EFS is designed to process high volumes of concurrent operations in a file system. You can send multiple operations in parallel to EFS using multiple threads and multiple instances. In this graph, we hold I/O size constant, and we use 10 instances and increase the number of threads per instance. And as you can see here, as we increase the number of threads, the IOPS increased. So again, this highlights EFS's distributed design, as we can continue to scale out to larger and higher levels of throughput and IOPS. There are a number of mount options that you can use to mount NFS systems. We do recommend using our default mount options. We recommend Linux kernel 4 or higher, and we recommend NFS client 4.1 for best performance. We recommend the 1 megabyte read and write buffer size. In other words, the maximum size of the chunks of data that the client and server pass back and forth to each other. This is the default for most modern kernels, but it's helpful to specify them explicitly just in case. And you can see here the other options that we provide. Now, because file system workloads are typically spiky in nature and driving higher levels of throughput for short periods of time, but then lower levels of throughput for the remainder of the time, we built in a burst model within EFS. Now, throughput is based on the size of the file system, and your baseline throughput is 50 megabytes a second per terabyte, and that's the throughput that you will be able to continuously drive. Now, you are able to burst above that up to 100 megabytes a second per terabyte stored when you're bursting above your baseline. So in summary, test your application, use a general purpose mode for lowest latency, or max I/O for scale out. Use Linux kernel version 4.0 or newer, and mount via NFS v4.1 for best performance. To optimize, look for opportunities to aggregate I/O, perform async operations, and parallelize as much as possible. And lastly, please keep track of your burst credits when you're doing your testing, so you can ensure that you have sufficient amount of storage for that baseline throughput. So, in wrapping up, we talked a little about Amazon EFS. We shared some examples of enterprise applications that are using Amazon EFS, and we talked about some things you should consider when testing. I want to highlight that we have a number of resources online, including blogs, white papers, reference architectures, and tutorials, and other documentation, all available on our website. So please visit aws.amazon.com/EFS for more information.